Okay, so today I'm here not to talk about Magento 1 itself, not to be embraced again around Magento core issues I did when I was working in Magento core team. Today I'm going to talk about Performance, and M stands here for Magento 1, Magento 2, and MySQL. So this is the main issues that most of the developers are facing every day, and I'm going to share with you some of the information about specifics of MySQL optimization itself in your Magento projects. So I will start right away from a small information about MySQL. It requires, like Magento core requires to be touched gently. The same applies to MySQL when you need to gently use its features. Otherwise you may make it angry and it will crack down on you. So what it means using MySQL gently itself? First of all, you need to know its tricks. You need to know its pitfalls. That's one of the things. Another thing, you need to analyze your slow queries. Excuse me, can we adjust the microphone a little bit because I hear? It has echo. Okay, so you need to analyze your slow queries, you need to take a look at the slow query log, use explain statement to find out what is wrong with your query itself, why it's performing so slow. Another thing, you need to use very carefully MySQL memory itself, because MySQL is also an application, and it also has memory limits. And if you run queries that are not meant to be memory efficient, then you will have a big problem in the end. So it leads us to another question. Maybe some of you can answer it. Actually, can we kill MySQL server? Okay, it's good. You know that it's possible, right? Another question, can we do it by a single query? Okay, then another question, very simple, can we execute this query with non-privileged user? Okay, so I see some people already tried it and maybe already had their MySQL server down. So what do I mean by these questions? What kind of issue we might have? We have two queries that are quite winners in killing MySQL server. And on most of the customer projects, they're actually killing it. Especially if customer has more than 100,000 of SKUs in their database. So what are the winners? First of all, it's insert into from select. When it's not optimized, it will crash your server. Like, it just will grab it and throw it on the ground. Another thing, it's update join set without any limits. It will also just kill it. So what actually happens, right? What happens with these queries? So first of all, MySQL creates a temporary table for each of these queries. And this temporary table may go into memory if you have enough of buffer pool in MySQL, or it may actually go into swap. And if you have a very low swap value on a server, what will happen? Actually, it will use all the swap in a matter of seconds. And if you run out of swap, your server is down, you cannot access it over SSH. So big success, how some my French people like to say. So what is the solution for this purpose? First of all, it's actually using ranged queries. Never do a full query on the whole data set with insert from select and cross update from select. And another one, writes memory or swap size. Actually, the second one I don't like at all, because this is actually not solving the problem, right? So what I usually doing, oh, it seems not working. Sorry. Okay, I'll stand near with the laptop. So the trick number one in my today's presentation, it is ranged queries. And the range queries, it's actually a query where you need to find out, first of all, the minimum and maximum value of your data set. So you just execute a very simple SQL query, right, to grab this data. so you know how many primary key matches will be in total. Then you need to decide what is your perfect batch size for your configuration. My favorite one is 20K. And then you need to execute the same query, but with particular ranged conditions for each of the batches. So instead of one insert from select, you might have hundreds, but they will be less harmful than one big query. So how to do it? How to do a range query? It's very simple. Like you have your entity table, right? You get max and minimum value if you'd like to do it for the whole data set. You can also apply some filters over there, right? Then the insert query is just simply adjusted when you have insert into some flat table, some data, select from some table, and then you put a where condition for the first batch, like from the first ID to ID 20,001. So this is kind of all the trick. It's much more efficient, it's stable, you are sure that your script and your application will run on any database set size. So you are not limited anymore to millions, hundreds of millions, whatever amount of records is. The only thing that with amount of data, the time actually increases. And for update, operation is the same. You just put a condition over here, like for the same primary key, you just specify the batch current ID values. So why is it better for MySQL? First of all, it works faster on huge data sets, because for MySQL it's much more easier to grab some small piece of data and process it instead of doing it for the whole pack of data. It consumes much more less memory on MySQL side. So you can serve more customers while actually doing some heavy operations with reindexation. So you don't need to put all your website down to run particular reindexation of the flat data on 1 million product database. Another thing, it has predictable time frame. So you can always do a progressive kind of expectation from with every data size increase. So let's take a look at some boring numbers. I like to use numbers in my presentations. So some boring numbers are here based on Magento 2 framework base. I actually did a very strange thing. I take out Magento framework, used its components without actually using Magento 2 itself. I created a database based on this framework, based on 1K items, 10K items, 100K items, and 1 million records, EAV-like structure itself. So it almost repeats the same structure as EAV tables, a little bit simplified. And I created a flat indexer based on these ranged queries. So this flat indexer run for different amount of data, different amount of time. If you take a look here, for 1000 it was only 270 milliseconds. For 10K it was almost 2 seconds. For 100K, yeah, it's increased dramatically. Like if you take a look, if you multiply this number by 10 and add 10%, you will get around this number. And then 100K multiplied by 2 and add 10%, you will get again a higher number. And then 20K multiplied by 5 and add a little bit more percents, because there's more steps in between, you will get this time. So you can see it might take half an hour to build a flat index in such a way for 1 million of records. But this is actually worse to do in such a way, because if you would just execute query without range limit, actually on 1 million records my query didn't finish, it just hung up my VM and I was unable to log into it. So what is the purpose of the flat index data itself? Like, we a lot use Magento flat index on the front end, try to retrieve the data, but the main idea of the flat index in Magento particularly is to filter the data that you have on the front end and to sort the data. So to filter the data, I mean apply a where condition on indexed column in the flat table. And by sorting the data, I mean actually ordering by also indexed field in this table. So there should be no more things than that for this kind of flex index structure. Flat index structure is not for data retrieval. You shouldn't put there everything you'd like to retrieve later on. It's easier to make another query just to retrieve this data from other tables. So if you don't need to filter by this data, don't put it into flat. If you don't need to sort by this data, don't put it into flat as well. So now we go to the trick number 2, right? So we know we have some kind of easily generated flat index for any amount of data we might receive in our database. So we have trick number 2, and this one is related to simplified queries. What simplified queries means in my opinion? First of all, it's actually instead of creating a query that will have hundreds of joins, actually separate all the joint data itself into separate queries that will be loaded for existing datasets. So remove any kind of data retrieval from the main query to improve the performance of the filtration and sorting process. Try to minimize join conditions on the simplified queries itself. So to remove additional joins for your data, for instance in EAV, you have queries like left join for store-based values. This one we can simplify as well by actually just adding order by store ID. And then when we receive a data set, we can simply override it later on, and we don't need to have a join condition in this case. And we can search for some easy override priority for our data as well. Let's say like for EAV, we can sort by store ID, and then we have first the default value, and then it's overwritten by the store value in our dataset, and we don't need to do any kind of crazy joins. So the main query in this case will look very simple. It just will retrieve the entity ID in the needed order. Then we have the data query itself. The data query will take data from EAV structure. So as you see, I'm taking data from entity varchar, and here I pass in entity IDs that I retrieved from previous one. Then I order it by scope ID. In my case, scope ID is kind of analog of store ID. And it means that I retrieve values for particular entities, attributes, and then I have scope ID, and also there is some value, but it's omitted over here. So I just walk through the data and set it inside of my retrieved already dataset. So I don't retrieve millions of records in this case. I retrieve only 20 records, 30 records, 50 records, whatever I need for this current page. And here's an example of really bad query. If I would do it the normal Magento EAV way, I would do it like this. I would take the ID itself, I would join as many entity tables as I'd like, and I will need to join the default table, I will need to join the scope table, and then put some kind of nice condition. If the scope table doesn't have a value, then I use default one. If it has a value, then I use the scope value. And this makes me really mad, because when I see these queries, like, they perform really badly on millions of records. I even don't see a good performance in thousands of records. And here's some of the benchmarks, but first I need to explain why it's actually better. I forgot about this one. So first of all, it doesn't create a temporary table to sort out the result, because as soon as you have any left join that doesn't limit query by index, MySQL will create a temporary table and will use a very nasty procedure of filling in your memory on MySQL side, and in the end, yeah, you may run into big issues. Second one, actually it's using indexes instead of table scan for filtering out the data. Third one, it works only on small data set instead of working on the million of records joined together. So you can imagine, like, you have million of SKUs. Every SKU has around 50 attributes, and you have, for instance, 5 scopes. So it means if you multiply all these numbers, you have milliards or billions, how you call it in US English. So it's going to be amazing data set. And can you imagine MySQL actually taking this data into a temporary table and then walking through it? Do you think it's going to be fast? No? Do you think MySQL will allow you after it? No, right? So you have to make sure everything is working correctly and you don't load all the data together in one select. This is a very bad idea. So I compared some different queries. First of all, I compared a join without actually applying any filter on the data. So I just join attributes together. And on 1000K, like the average response time of the MySQL itself to this query was around 20 milliseconds. For the same kind of joint query, but now with the join filter. So I was filtering by joint table of the attribute that doesn't have an index. It's increased because it was a table scan in order to find out the filter value itself on particular row. Then I also created a filter by flat table. So even if I have a flat table joined to the main select, still it not performs that much better than original request without filters. But then I created separate queries. So first I retrieved IDs and then I retrieved all the rest of the data. And in this case, all the queries together was returning the result within 5 milliseconds. So this is the result that is much more better even on 1000 SKUs. So it's not a big database, right? But so dramatical improvement. We don't need to create flat tables like in Magento 1. We have flat tables for all the data that we'd like to retrieve on the front end. We don't need to have it for purpose of retrieving the data. We just can do a separate query to AV structure and grab it from there, right? We don't need to have this kind of very heavy indexers. We just need to index the data that we're going to use in filtration and in sorting. So this is kind of relief of your database server when you implement it in such a way. Then for 10K, right, very similar results. Sometimes, apparently, it's even a little bit faster. I don't know why. But if you take a look at, let's say, flat filter, here you have a separate query with a flat filter. On 10K, sometimes it shows a little bit higher result than on the 1K. And the problem I expect over there is internally because it has to grab a little bit more buffer pool and it may run into some issues with that. But when we go to 100K, you see like the AV structure is almost on the same level, like it's all the time almost the same amount of milliseconds. There is not that much difference, like it's stably slow, right? Then we have 1 million records, and you can see that this one green bar, this green bar here, here, and here, they're all the time on the same level, like on 5 milliseconds. So this is also quite stable result to retrieve the data from separate queries. And I think if you can load products on a page within 5 milliseconds of database operation on a million record database, it's a good achievement for your category page, right? You don't need to do these crazy queries like at the moment Magento does. If you do database correctly, you can pinpoint the problem, separate the queries, and make it more simpler for database server. So it gives you better results. And the trick number 3, like we know about separate queries, but there's also another thing, it's actually limits. Let's say if we have to retrieve a data set of 100,000 of records. If we go to the end of the 1,000 data set, our limit operation will be incredibly slow. So for this purpose, we can separate limit from the main query and use the limit only on one field, on our main primary key. We can apply sort order on this limit operation, so we don't need to order actually our main query because we already have ordered list of IDs to which we just apply our data. And we just can retrieve the data from the main query by applying a filter from IDs retrieved from the child query. from the limit query, sorry. So limit query looks quite simple. Also, I retrieve only ID, I apply some filters, for instance. I retrieve data from flat table, not from entity table in this case, because I only use tables that is used for filtration and sorting. Then I order by first name, and I retrieve, for instance, first 100 of records. Then I take the main query, the one that was with these terrible joins, that was performing slow originally, and I just filter it by IDs. Now it performs a little bit better because even joins on a smaller data set are much more faster. So why is it better? First of all, it allows to access last pages on huge data set with the same reasonable time frame. And it does result set scan only for one field for your primary key, not the rest of the fields. So how it affects our numbers? If you take a look at retrieving the first part of the dataset and the last part of the dataset randomly, I did some benchmarking for this process, and it retrieves around 50 items from beginning and from the end of the dataset all the time. So for 1K, the difference is still visible. Like, it takes only 20 milliseconds to retrieve this data for limited range limit, and around 70 milliseconds for a regular one. For 10K, you see the regular one increases dramatically, something like, by a factor of 10 at least, comparing to the range limit. For 100K, it's even more worse. You know, like with the size of the data, the time to walk through the whole data set actually multiplied by the size of your data. And from 1 million, it's incredibly slow. So if you want to go to the last page of 1 million record data set, you have to wait 72 seconds. Do you have customers on your websites that are ready to wait for so long time? I don't think so. But if you apply this range limit query, it's still slow, but it's reasonably slow. Because you have to walk through all the million of identifiers and find the ones that are placed in the end. And this operation is much more easier for MySQL to walk through, because sometimes MySQL even can use index scans instead of full table scans, if you don't have that much sort orders. And finally, the last trick, the most interesting one, especially when you try to export huge data sets of data from Magento. So let's say you want to export 7,000 of products, and you want to still achieve a good performance on retrieving a separate EAV table structure. So for this case, you would usually use a memory table. And the memory table, it's a very interesting trick because you actually retrieve the first data set with all the identifiers of your entities. You put it into the memory table with only one column, that is your primary key. And then you just retrieve data from dataset selects itself by joining this memory table into it. So you don't need to create a huge query to MySQL itself, because it already has data in separate table. So you supply these IDs once, so it takes less time on MySQL side to process and parse your MySQL query. It's one thing. And other thing, condition in MySQL is quite slow if you have a huge amount of IDs itself, and if you are short on the buffer pool size. So if you have, for instance, 128 megabytes of the buffer pool size, you still can export millions of records within a reasonable amount of time if you use this trick. But if you try to use in statements, you are limited to around 1,000 of items within in statement, because otherwise then you have a huge performance penalty. And on the struct of your resource model, you can actually drop this memory table because you don't need it anymore. So next time when you do an operation, you just create a new one. So how to create a memory table in Magento? This code actually applies to both Magento 1 and Magento 2, as they are using the same methods of the similar API structure itself. This one particularly is Magento 2 based. You can access a connection, you can create a new table, you can specify some unique ID into it because it should be unique for every operation you have. You don't want to have it collided. Then you create a column ID. You put a type to this column the same as the primary key on a table you are trying to access. The same configuration should be specified in size if you have some custom size as well. You specify this as unsigned because usually primary key is unsigned, and you need to set it as primary. And then you need to set an option called type. I did multiple times some mistakes while developing this kind of memory tables when I forgot to specify type as type option, but I was specifying engine because Magento has a constant name engine, but the property to specify this constant name engine is actually called type. So this is a little bit of confusion in Magento core. Probably not the last one you will meet during your Magento 2 education, right? And then I just execute create table statement, and it just creates our memory table. Then I need simply to populate this table with insert array method. So I take the table method called getName. I specify the ID column, which I'm going to fill in, and I need to specify an array of IDs. That's simple statement. Then I join a table that I fill in with the ID itself. So I just join this table to select. I put a condition on entity ID by this entity ID field that I've created. So this is quite simple, right? And when it's actually better is more items you have in statement, as more chances that you actually need to use a memory table instead of in statement. And here is a little bit of comparison of performance on 10K database. On 1K, it was almost invisible difference. So if I'm going to retrieve 50 items from a data set, so I'm going to create an in statement with 500 items itself, then the regular in statement will take 50 milliseconds, the memory table will take 30 milliseconds. So already a small improvement. If I'm going to retrieve thousands of items, on average it will take 70 milliseconds, and memory table will take 20 milliseconds less. And if I'd like to retrieve 2,000 of items, right, it will take 100 milliseconds and 90 milliseconds accordingly. So as you see, most of the time it's faster and faster comparing to regular in condition. On 100,000 items database, it's even more visible because as bigger data set, as more busy buffer pool of your MySQL server. So it means less space is left for in statements optimization. And here, as you see, the difference for 500 items is now doubled. Almost the same for 1,000 and better for 2,000 of items. But for 1 million, the difference is not that big, but still reasonable to use memory tables as well. So if you retrieve 1,000 of items, it's only 10 milliseconds difference. 2,000 of items, it's actually 20 milliseconds itself. For 3,000, it's also 20, and for 4,000, it's 40 milliseconds difference. But there is a big issue. If you have very sparse list of identifiers, then you have slower join condition itself. It's related to internal specifics of MySQL because MySQL needs to scan your primary key index itself, and if you have big gaps in between IDs, it takes more time for MySQL to join another table. So how it affects the values? I took 100K records and ordered IDs in random direction, not one by one. And in this case, on 500, it still was okay result because there's not that much data to process. But in statement was even worse, because internally MySQL doesn't optimize in if there is too big difference in IDs, if there is big gaps in between them. Then we have thousands of items. Now they are showing more or less similar result. Still, memory table is faster. For 2000, the same. Memory table is still faster. But when I did it on 1 million records, both of them were very bad at performance. And mostly because here we have much more bigger gaps in between IDs, because we have million of records instead of 100,000 of records, right? So we can have bigger gaps in between our ID condition. So as you see, on Retrieving 4000, in statement even was faster than memory table. So you need to make sure that if you want to export big data sets, you need to order your IDs one by one. Do not do it in random direction. Otherwise, you will run into performance issues while retrieving this data. So this is the last one, but not the least for you, because you can grab all the code I was used to generate the data and actually to perform these benchmarks on my GitHub. ecomdev MySQL performance benchmark. Just do git pull, do composer install, and enjoy some MySQL benchmarks, and see if you can use some of this stuff in your projects. So if you have any questions, feel free to ask.
They are afraid.
Okay.
So, impressive, but it takes a lot of time to apply this to all facets of Magento. If you would name one page or module where we should really do this, like today.
Okay, it's very good. I have a very good example. Like every Magento project has some kind of export of the product data somewhere. Let's say it's Google Sitemaps or feeds to bol.com if it's in the Netherlands, or I don't know what's in Italy, an analogy maybe eBay or whatever. Like if you need to export big data set of data, you can already apply all this kind of functionality for this purpose. Or for instance, right now, if let's say your customer needs a lot of attributes to be shown on product listings, you already can apply additional queries to load the data from EAV structure instead of doing adding of the columns into flat table. Because as more columns you add to flat table, as less possibilities you have later on to add needed filter and create index basis filter.
Right, so a list page with a lot of attributes using the Simplified quick win.
Yeah.
Thanks a lot.
Well, I have a question, and the same question every time I see your presentation. Being one of the few guys allowed to change the core, why didn't they let you put this optimization in the main code base?
Okay, it's a very good question, really. First of all, and the most important reason is backward compatibility. Okay, it's fine to apply such kind of tricks on your custom projects, or let's say create an extension that will apply these tricks to your project, but you need to revise then your code base in order to use the same approaches, in order to add the data to the needed hooks inside of the optimized code instead of doing additional loads of the data from standard Magento way. So this is one of the main reasons. Second reason, I think it's because we don't have a really public process of contributing and participating in Magento core development. Because, yeah, I had already some experience of contributing to core and actually not getting in response from them and then implementing future in another way. So